I'm going to work practice set 3 on a different sheet of paper. I just can't fit it all on here. So again, this is practice set 3, and I'm just going to use a blank sheet of paper. So I will label. And it says to list all positive factors of these numbers and identify each as prime or composite. So number 1, our number is 30. So we have 1 times 30. We have 2 times 15. We have 3 times 10. 5 times 6. So 30 is definitely not prime. So let's call it composite. Here's your composite number, and these numbers underneath are the factors. Number 2, we have the number 22. So 1 times 22, but we also have 2 times 11. So this is not prime. It would also be a composite number. Let me move that over, and I think I can fit one more right here. Number 3 is the number 28. So definitely not prime. I know it's divisible by 2 because those are both even. So we would have 1 times 28. 2 times 14, and 4 times 7. So that is also a composite number. Number 4, I have 16. So we have 1 times 16, 2 times 8, and 4 times 4, making this a composite number. Number 5, 60. We used this one in class as an example. I know it is not prime. It has a lot of factors. So we have 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. Lots of factors. Number 6, 87. I know 1 times 87 will work, but is that all? 2 won't work because it's not even. Let's try 3. It may be prime. Nope, it's not. 3 times 29. 4 won't. 5 won't. Let's try 6. 6 won't. 7, 8, 9, 10, 11, 12. I believe that's all. Possibly 13. No. 14, 15, 16. The only other one I can think of is possibly a 19, and that's not. So I don't believe there are any more, but we can already say that it is composite. Number 7, we have a 68 to work with. I know this one is not prime because it is an even number. So because it's an even number, we know that 2 would work. 3, I don't believe will. 4, Yes, 4 times 17. I'm using my calculator. 5, 6 won't. 7, 8 won't. 9, 10, 11, 12, 14. I don't think so. 16. I don't think so. No. So those look like all, but it is composite. Have we had any primes in this list? 99. Well, 2 won't work on this one, but a 3 will. 33. So it is not prime. Number 9 is an 85. 2 won't work on this one, but a 5 will because it ends in 5. I'm not sure how many times it'll go. Let me check 3 before I know. Okay, 85 divided by 5 is 17. So this one is also composite. It's composed of many factors. And then number 10, 72. I know that's not prime because it ends in an even number. So it's divisible by 2. 72 divided 2 is 36. 3, I believe, will work as well. Whoops. Yes, and because 2 and 3 work, I know that 6 will work. 72 divided by 4, that'll work. 4 times 18. We know that 6 works. 7 won't, 8 will. And that's times 9. So that one is definitely not prime. Okay, the next one tells me to list the prime factorization for each number. So for a 48, first thing that comes to my mind is 4 and 12, but you can use any that you want. Just remember to bring them all the way down as far as they'll go. So this one is 2 times 2 times 2 times 2 times 3. You could also write that as 2 to the 4th times 3. Number 2. Our number is 35. So 5 times 7, and both of those are prime. So that is your prime factorization. Number 3, 46. I know that 2 and 23 will work, right? 46 divided by 2, yes. And those are prime. So 2 times 23 is your prime factorization. Number 4, 40. I think of 4 and 10, but you can use any that you think of. That's 2 and 2. That's 2 and 5. And there we go. 2 times 2 times 2 times 5. Or 2 to the 3rd power times 5. The HESI Prep book leaves it in this form. So that's what I would look for on the answers. 100. To me, that's a 10 times a 10. And each of these break down to 2 times 5. So 2 times 2 times 5 times 5. Or you could write that as 2 squared times 5 squared. Number 6. we have the number 66. And for this one, I think of 6 and 11. And then 2 and 3. So 2 times 3 times 11. Those are all prime numbers. So that is our prime factorization. Number 7, 75. To me, that's a 3 times a 25. And I break that 25 on down. I have 3 times 5 times 5, or 3 times 5 to the second power. But either way, we have prime factorization. It's important to use those terms. Say them out loud as you're doing them. 8 times 9, and neither of those are prime. That 4 has to go on down. And then the 9 is 3 and 3, and those are prime. So I have 2 times 2 times 2 times 3 times 3, or 2 to the third power times 3 to the second. Number 9. Sorry, I keep forgetting that I have to switch that over. 65. Oops, I'm not doing that on these, am I? Okay, so 65. You might have to think a little on this one. It's going to be 6. No. Yeah, 6 times 13, I believe. That's not it. 5 times 13. I knew 13's in there. 5 times 13. Those are both prime. So there is your factorization. Miss Amanda is tired today. And I get careless when I get tired. I'm going to use 9 times 9. That's a perfect square. Those each break down to 3 and 3. So my prime factorization looks like that. Or you could just say 3 to the 4th power. And I think I'm going to stop this video. It's getting a little bit long, and then I'll come back in part 2 and we will finish this.